Please be patient as we begin our live stream. That will take a couple of moments. All right, very good. Welcome to our Learn It Live session, Applying Machine Learning to Predict Consumer Spending, with Sunil Narsinghani, the author of ABC of Machine Learning. This is going to be a fascinating session. And first, my name is Stuart Creek. I'm a marketing manager at Simplilearn. I'm going to share with you the instructions for using the WebEx controls. If you're not familiar, please do put all your questions for Sunil into the Q&A box. We will queue those up and we will get to those at the end of his presentation. You can put chat in if you want to address it to Sunil or myself, put all panelists. And with that, I will start our first poll. We'll do one at the beginning and one at the end of the session. And our poll at the beginning is about you. And just to give Sunil a feel for the audience, please tell us how much work experience you have. And we have a second question on the poll. We're checking in with people, how they're doing today, especially with the new news of the Omicron variant. We are all getting strange and stressful messages during the pandemic. So we like to check in with people and see how they're doing. And just get your answers in, and I will share the poll results now. And we have a bimodal distribution, Sunil. We have a number of people who have more than 10 years of experience, and we have a number of people who are still in school, and a smattering of people in between. So you have an interesting audience to speak to today, and I will close the poll and introduce you. Sunil Narsinghani is the author of the ABC of Machine Learning, Technology and Business Visionary. He's been in the field for 20 years, specializing in machine learning and data science and the application of that to interesting problems. He's worked with WinWire Technologies, Mindtree, Mu Sigma, Oracle India, and holds his master's degree in industrial engineering and management from IIT Kharagpur. Kharagpur, I'm sorry. So Sunil, we are very pleased to have you here today, and welcome. You're on mute, Sunil, so I'm going to unmute you. Here you go. Can you hear me, Sunil?
Yes, I can hear you.
Okay. Yeah, I can hear you now.
Okay, is my screen visible?
I am going to give you the sharing privilege so you can do that. Why don't you tell us just a little bit more about yourself and how we came to this problem today, and then we'll get into your presentation.
Okay, I'm Sunil. always in search of some new application of machine learning or some new algorithm of machine learning. I was always very much interested in ordinary least square and regression, but I was always interested, like, there are so many types of regression. What best we can do with them in machine learning and data science? And then I found this new algorithm. This is something inbuilt in both R, Python, and other libraries, but not much used, not much talked about. So I got very fascinated to know about it, and after knowing about it, I was very keen to use it somewhere. So a couple of places where I tried using it one was of course customer credit card spending. Other place I tried to use it was blood pressure of human bodies, how it can be predicted better using quantile regression. So quantile regression was something came up very fantastically well, and I jumped on this.
Great. So why don't you go ahead and share your screen now? I think you have the ability. Not seeing your presentation yet.
Okay, can you hear me?
I can hear you. Yeah, you probably want to turn your video off and share your screen.
Okay, so in this presentation, we have certain objectives. We'll talk about that. Then we'll talk about quantile regression, what it is.
Sunil,
What
I'm
best
still
can
not
be done
seeing
with
your
this.
I'm still not seeing your presentation on your screen. Can you make sure you're sharing it? If not, I will share it from this side.
Okay, is it visible now?
No, it is not. Let me share the slides from this side.
Okay, let me try last time, just one second.
Okay.
Is it visible now?
Yes, yes, it is. All right. I apologize to everyone for the technical difficulties. I can tell you it went perfectly smoothly in rehearsal, but this is the nature of live television. So with that, I'm going to turn off my mic and let you go take over, Sunil.
Fine. So we'll talk about what is quantile regression is all about. Then we'll talk about the random forest. Then with these two techniques, quantile regression and random forest, comes the quantile regression forest, and we'll talk about that. Then we'll take up out the credit card spend prediction. Here, this is just more like an example and not a case study. We have simulated some data and tried using it for our demonstration. So we'll show you some input data. Then we'll show you what output comes out of the quantile regression forest. So after this presentation, which will last for around 60 minutes, including 10 minutes of Q&A, we'll learn quantile regression forest and its implementation to credit card spending or credit card expenditures, or to predict credit card expenditures. So first foremost thing is quantile regression. So as I said, first, we all know about linear regression, predicts the conditional mean and the point prediction. So suppose I want you to predict a credit card spend of some user, you will definitely predict something like $750. But that 750 is just a mean or a point prediction. But what quantile regression predicts is it predicts the conditional quantile. Conditional quantile means I will tell you the median of the expenditure will be $740, but it will move between $700 and $800. So I am going to give you a range prediction. And that is the best definition of quantile regression is it gives us a range prediction, range on the basis of quantiles. We all know quantiles very well. We must have heard about percentile. We must have heard about quartile. All these are example of quantile statistics of some data. So quantile regression predicts a range based on the quantiles. Uh, Quantile output is a range. It might be more useful. Example, as I told you, a credit card person may spend 1100 to 1500. Now, 1200 is very fine number for this, but it may definitely go wrong. There is some uncertainty comes up. 1100 to $1,500 range. When we talk about range, lot of uncertainty get covered out of that. It hides the uncertainty, and the lower the range, smaller the range, more confident we could be how much will be the spend, and that gives us lot of advantage. And we can say that 90% of chances are there that 11 the spend between will be between $1,100 and $1,500, and that gives lot of advantage. How? I will come to that. But remember, if this range goes bigger, that also happens, our advantage will be diminished. We will be in less advantageous position if we if this range is very big, and we don't want that. We want this range to be predicted, and it should be as small as possible with certain degree of percentiles, 10 percentile and 90 percentile values should be very near to each other, and that is what quantile regression gives us. You must have heard about term homosexasticity, that linear regression is having a compulsion that data, or it's having assumption or very strong assumption that data is having homosexasticity. That means if if you have y is equal to mx plus c plus epsilon, epsilon is the error we have not measured. The epsilon always follows a normal distribution. This is a normal distribution, and the variance will always be same, and this is called homosexasticity. So quantile regression is contrary to this. Quantile regression is good in case of heteroscedasticity as well. This restriction is not there on quantile regression, and that is another very big positive point. How it is a good positive point, I'll come to that in my subsequent slides. Quantile regression can be solved by a method very similar to ordinary least square method, but it can also be solved by random forest. And random forest solves it better. That's why we created our presentation by solving it using random forest method. So we will solve this regression problem with the random forest. Now, what about a random forest? Random forest is made up of two words, random and forest. Random stands for the randomization we do when we pick up the data and create a random forest. So in each decision tree and each split, we choose a certain rows at random, that is a sample, and we also choose certain columns. Not all variables participate in creation of tree, but certain variables selected at random participate in creation of the tree, and that is why this is called random forest. Forest stands for large number of trees. So I am assuming that all our audience is familiar with the tree method or tree technique. Decision trees, by tree I mean decision trees. So large number of decision trees are created in the random forest. That is why the word forest comes out, because forest means lot of trees. Solving classification and random forest solves both classification and regression problem. It calculates mean value of the target variable for each leaf tree when we use it for regression. But it can be used differently as well as we use it in the quantile regression forest. So most of the technique is same, but and hundreds of trees have been used, but they are used differently when we solve a quantile regression problem from the random forest. Now, giving you better insight of random forest is, suppose you see this picture on the right side. There is a big circle on the left of it. That is the whole population. Then what we do is, we do bagging. Bagging stands for bootstrap aggregation. And in the bootstrapping, we take out small samples which are represented by smaller circles on the right side. Once we say, and on each boosted sample, we create one tree that is created as a tree icon here. And once we create large number of trees, we combine the result of all the trees and create a consolidated result, and that is called aggregation. So random forest is a method of bootstrap aggregation, and there are 4 parts to it. One is a big population sample, there are subsampling, there is decision trees, and there is aggregation. Random forest is mostly used or predominantly used in sampling technique in machine learning. I mean, in sampling is large number of models are created to create a consolidated model and a consolidated prediction, which is always better than the individual, which is called a weak learner model prediction. And random forest is a prominent method of ensembling, and in machine learning it is used predominantly. Random forest also do one very basic thing, that is bias and variance trade-off. Bias and variance are two constituents of error. Random forest tries to minimize the total error by reducing the variance, albeit bias also get decreased in the real world. Hypothetically, it increased little of bias, but it reduced substantially large amount of variance. And with that said, it does bias variance trade-off and reduce the total error. So as it reduces the total error, random forest predictions are lot more accurate than other methods, which may not be doing this kind of bias and variance trade-off. So with this little word about idea of random forest, I go to the third technique that I want to introduce you to, that is quantile regression forest. It is made up of 2 words, quantile regression and forest. This is just another version of quantile regression, another version or other variant of random forest. So that is why forest word is incorporated from there. It just tweak the way regression problem is solved in the random forest. While QRF method is for regression, in this method, trees are grown as a standard random forest algorithm. So until trees are grown, there is no change in the quantile regression forest technique and random forest technique. Once trees are created, what happens is, see, in usual regression, if you solve in the with the random forest, it takes mean of all the nodes, all the tree outcomes came out. But in the quantile regression, it just creates, or it just obtain, instead of mean, it obtains all the values from all the trees in a particular node, and it creates, I repeat, it creates a distribution based on quantiles. So this gives us a tremendous advantage. We solve the quantile regression, and we have a distribution of our prediction outcome, and that is something different than the random forest technique, the raw random forest technique. Example I have given, I have 50 trees. So in random forest, I will get 50 predicted values. And I will take the mean of that. But in quantile regression, I will create a distribution out of 50 predicted values from the 50 trees of my random forest. uh, when we get the distribution, we also get a confidence interval in the quantile regression forest. And that is something we want. That is something we will use. Quantile regression forest is a non-parametric method. And it is an accurate way, much more accurate way than using a OLS method or OLS kind of method for regression forest. And it can accommodate very high number of predictor variables, which is very common case nowadays while solving machine learning problems. Nowadays, if we are solving machine learning problems, we get large number of variables or input variables or predictor variables, and quantile regression forest handles that thing extremely well. So that is why we are preferring quantile regression forest over other techniques. Uh, Target variable again could be heteroscedastic. Its variance can be changed, and that is how it is. Now, I had taken 3 slides just to explain the basics of quantile regression forest. Now I will jump to my example. My example is for credit cards expenditure. And credit card expenditure is a business in which we want to know the credit card spent by individual users. This gives us a fairly good understanding how much will be spent on credit cards and who will spend how much if we can predict accurately, and this gives us enormous advantage in the business. So it is a data science problem, it's prediction problem, it's supervised learning problem in this. And usually banks have millions of users. Typically every person have multiple credit cards, and there are multiple credit card users available, which counts into millions, and uh, they spend and pay back to their respective financial institution like banks or other institutions on monthly basis. So each month a bill is generated for every credit card user. I am very sure most of us will have a credit card, and most of us will be paying to some bank the credit card bill each month. So our data input data is the combination of monthly expenditure of credit card user. Now, we all have credit limit, but we spend differently because of our behavior. So predicting the credit card expenditure is actually predicting the behavior of the credit card customers. Few of us pay more, few of us spend more, most of us spend moderately, few of us spend drastically low, and all this information need be obtained. Who is extravagant spender, who is the spender who spends less, who is the spender, who is the user who will maintain his credit card, who will pay almost constant amount each month, and what is that constant amount that helps us a lot, and he will pay the bill each month. So uh, all this information helps the banks how much money will be offtake in the credit cards. Factor other thing is most of the banks want to know which are the variables or which are the factors driving the business of credit card spend, and our tool should be in a position to tell us what is driving, what is difference between two users with the same background. One spend a lot more than the other one. So what is driving the thing? Because we assume that both the users are same, but something else is happening because of which one user spends a lot more than other user. So this is again, as I said, it's a behavioral problem. And we of course want to know the variables which are driving the business or factors which are driving the business. Now, to solve this problem, we needed a lot of data, but we were not having much data. In fact, we had no data at all. So what we did was we did some research in the market. We saw all the statistics, some plots, some reports, and we vaguely determined what are the factors determine the credit card expenditure. So we taken all that factors and simulated some data. We simulated something like 9,000 records of data. 9,000 man month or user month of credit card bills were simulated in our data. And the factors we determined was credit card limit, how much a person is allowed to spend, gender, number of dependents an individual credit card user has. Someone has four dependents, someone has 3 dependents, someone has 2 dependents, all that. Income is in dollars. Sorry, dollar sign is missing here. This is 61,000 is annual income of individual user. It is not monthly income, it is annual income. Here we have assumed that income will remain constant between months, and the data is for 1 year. So, but for whole year the income will not change; it will remain constant. This was an assumption, and we simulated the data for average income of a citizen, and this is something like 68,000, 88,000, 125,000. These are just the 10 lines of data. We have actually simulated 9,000 lines of data. Other important factor we considered was employment status. Again, we assume that employment status does not change whole year, and people who are employed will remain employed whole year. People who are unemployed will remain unemployed whole year. And we have already determined one more factor, that was marital status. People who are married, people who are single, there is substantial difference between their buying pattern and their expenditure pattern. So this is again a simulated column, a simulated variable added to the total data set, and there is age group. So we learned from various reports that age group is an important driving factor with the credit card spend. Gen X spend a lot more than Gen Z, and baby boomer spends differently than millennials and other people. So we actually have these users or age group in the same proportion as they are in the natural data or the actual population of the people. So if Gen X is 20% of total, in actual population also 20% people are Gen X people. But end of the day, it is simulated data. Hence, please do not try to judge it with the real world knowledge we all have about credit card spending or the financial market of any country. This is all simulated data. It will not withstand the rules we have in the we have in the real world scenarios. There are 8 variables. I described all the 8 variables, and there are total 9,175 records used for expenditure. So with this setting done, what we have done is we created few, not few, in fact, one quantile regression forest using R tool. R is a very famous statistical tool. We all might be familiar with that. And we divided our 9,000 records into 80% for training. We did our design as 80% for training and 20% for testing. And we predicted, after creating the model, we predicted all the values we had in the 20% of testing data set. And first question anyone will ask is, what will be the median credit card expenditure? And this is the result we obtained. Median credit card expenditure of user will be according to this table. This table is having 3 columns, so quantile 0.1, quantile 0.5. 0.5 quantile is the median value. This is the in between, the centermost value of our distribution obtained from the regression forest, and quantile into 90 value is the highest value. Other thing I would like to say is, see, this is a cumulative distribution values. 0.5 percentile include 0.1 percentile as well. 0.9 percentile includes both 0.1 and 0.5 percentile as well. That's why all the time, every time you will find that if you move from left to right, values are increasing, and they always increase this way. Once we found this, we all know the distribution or the range, I should say the range of expenditure of each and every user we have, how they will spend in the coming month. And this is how it is given here in the result. This is 9th and 10th percentile. This 10 and 0.1, that is 10th percentile, and 0.9, that is 90 percentile, and median is something we have given for prediction. We can predict between 1 percentile to 100 percentile, 100 values as well. Usually what people do is they predict between 5 percentile and 97.5 percentile values. Usually people also predict with the 25 percentile, 50 percentile, 75 percentile, and 100 percentile as well. So these values can be determined as per our use case and our need. I had taken it as a usual case. We take median 0.1 and 0.9 percentile. Now, we have predicted these values. First question anyone will ask is, how confident we are about this range? So what we did was, we took 20 records. We took 20 records and we took the actual and compared it with the 10, 50, and 90 percentile. Out of 20 percentiles, we have realized that 2 out of 20 cases, it has gone beyond the range. You can see this 12 number value has gone beyond the range, and you can see that 16 number value has gone beyond the range. We have yellow marked the values, 2 values, which have gone beyond the range. So we can be 90% sure that our value predicted, the actual value, will be in the range we already predicted. Only 10% of time the value will go beyond our range. And this result can be plotted in multiple ways, including box plot, including bar chart or anything. We have plotted in a line fashion, and you can see that the yellow line always remain in between gray line and the blue line, and it always chases the orange line, that is our median line. With that said, what we are saying is, if we predict with a quantile regression forest, most of the time our prediction will be very close to the median value, and very seldomly or very rarely they will jump out of our 10 percentile and 90 percentile range. And this is how the prediction result will look like, and how we can say that how confident we are. We are 90% confident, or we are confident that 90% of the time, I should say, our values will fall into our range. And this is the biggest advantageous result we obtain for quantile regression forest from this thing. Now, as I said, we always want to know, or we as a bank, we as a financial institution, we as an analyst, always want to know what drives the credit card expenditure. We took a random forest. Every time random forest is executed, a byproduct. Why? Because Primarily, random forest gives us the prediction scores. Random forest as a byproduct also gives us the variable importance plot. I mean variable importance plot is it tells us which are the variables which are determining the results or playing very key role in determining the result. And here the results we have drawn or we have found is like this is that uh, biggest factor that is determining the result is income. People have higher income, higher running income, not the wealth. Wealth is a very different thing. Wealth is not considered in the random forest. They spend the more, and this is the most important factor. So to predict what is most important is income. Followed by income is credit card limit. Here we are assuming that credit card limit will be 10% of income, which is not very correct in the real world scenario. Why? Because in the real world, each user will have multiple credit cards. And while giving the credit cards, bank considers that how many more credit cards you have or how much more credit limit you have with other credit cards. So credit card limit also plays very important role in real world also. And in this scenario also, in the simulated data, this has shown that credit card limit is the second most important factor. Third most important factor that came out is number of dependents. Number of dependents are a two-way dexterous variable. It impacts both the way. If I have more number of dependents, I may spend more because of their needs. But considering I have more liability, I have to look after many more people, I may spend less on the uh, items which are discretionary. Hence, the number of dependents is another albeit dexterous but very important variable in determining the credit card spend. And this is how other variables are also listed. And random forest gives us this results very well. How the results are given is it ranks the importance of variables in regression, and this is how it is given. The outcome of it is determined. The order is node purity. Node purity is included. Node purity is the thing random forest use for determining the variable importance. The importance result can be changed with other metrics as well. Like there is one more matrix is used for error measures, but we have used the node purity, which is generally used method to determine the variable importance, and this variable importance is given here. More than that, banks always interested to find out if who will spend more. Where are my extravagant spenders, spendthrift people, spendthrift users? Given two users have same credit limit $100, one person will try to spend more than $100. In fact, total $100. Another person will just spend $30. Even if rest of the things are same, their background is same, their income is same. One person is a spendthrift, other person is not a spendthrift. And this is again a behavioral thing. Many of us behave, all of us behave differently. So uh, uh, all of us behave differently. And banks are always interested to find out these kind of people. One, they are the business. They bring business to the table because if they spend more, bank earns more as a commission or as an interest payment, and same time they are risk as well because they spend a lot. Giving them credit limit will spend a lot. They will spend a lot, and they may not be able to pay back uh, the debt. The debt occurred on or the bill or credit card bill. So this is a two-way thing, and we have drawn is something like we take a 97 percentile prediction that how much maximum they will pay, maximum they will spend, and we had taken their actual spend, and we had taken the difference between actual spend and predicted spend divided by their credit card limit, So here actual minus predicted by credit card limit gives us some numbers, and we've taken 5 out of 9,000 highest spendthrift people, and one person has spent more than 14% of it their predicted value, and next person has spent 10% more. These are just the simulated numbers, but these are just the simulated numbers, but they are extremely useful numbers. They tell us a lot about the behavioral pattern of individuals. Not only the top 5 people, bank may be interested in to know the uh, behavioral pattern of each and every user, and these are the results can be obtained by quantile regression forest. The method to determine this is derived by me, but different methods can be derived by seeing the data, seeing the metrics we have, and these percentage numbers can be differently obtained, or the same outcome can be differently obtained by different metrics as well. So with this, the quick presentation, I will open the floor for questions. So kindly tell us the questions, and we will discuss the discuss discuss about your questions now.
Okay, Sunil, we have a number of questions from the audience. We have some that came in from our YouTube live stream as well. And most of them are pretty technical. So Sweta asks if we have a highly positive correlation between variables in the data set, and those columns are very important for our prediction, and we can't remove those columns. How do we move forward with that data set, and how do we fit it to our machine learning model?
Fine. See, correlated variables have one method in our regression models or in the prediction modeling is regularization. This phenomena is known as multicollinearity, and random forest handles these correlated variables well. This is one of the reason people use random forest, because what random forest does is you may have few variables which are linearly correlated to each other and you cannot drop them. But while creating the trees, random forest will take few of them and will not take few of them, and random forest will take this decision at random.
Mm-hmm. Okay.
And hence this thing
Go
is
ahead.
inbuilt into the random forest and it takes care of that. Otherwise, jump to the quantile regression technique, which is very similar to OLS, and apply the regularization method. That will also solve the problem.
Okay. Zaina Truman asks, can random forest be used for time series prediction? And if so, how?
See, time series, it is not actually time series prediction, but it is time series forecasting. Whether
Okay.
random forest can be used for time series forecasting, I'm not exposed to that. But for time series forecasting, there are other methods in machine learning data science world, which is known as recurrent neural networks.
Okay.
Quantile regression can also be solved by deep learning method, but all the methods are not included in that. But time series thing is little off track to the random forest, little off track to prediction modeling, and it more falls into the sequential model basket that is solved by recurrent neural network. So I would advise, like, let us try to use other techniques which are more prominent for time series forecasting.
All right. Umesh asks if you could go into a little bit about the difference between decision trees and neural networks.
Decision tree and neural network is, see, decision tree is something like a recursive partitioning division method. Here it is non-parametric method, while neural network is a parametric method. Neural network is deep neural network is having layers. There are a lot of weights, and they use back propagation to generate a prediction outcome. Uh, Quantile regression can be solved by both the decision trees or regression tree and uh, deep neural networks both. There are a lot of differences between both of them, But yeah, quantile regression, what is the topic of today, can be solved by both deep neural network using different loss function and with a regression forest as well.
Clifford asks, in hindsight, the analysis and the technique seem logical, but it's rarely the case when you're looking forward. So he's curious, in your process, what attempts did you make which failed, and how did you learn from those failures?
Uh, I actually tried to, this technique is very good, and it actually, I tried this technique. Where I failed with this technique was with the stock market prediction.
Mm-hmm.
And I failed in the stock market prediction, which was very just recently asked question, was time series kind of thing. Why time series kind of thing does not fit with this technique was because I realized that there is very basic assumption in prediction modeling that is known as IID, independent and identically distributed thing. What happens is, if we are predicting the credit card spend, each credit card spend is independent of a previous credit card spend. But in the time series or in the these kind of things, where I failed with this technique was, I realized that our current data point is very much related to previous data point. Today's stock market data is very much related to yesterday's stock market data. At these places, this technique fails. Other
Mm-hmm.
technique, the place this technique will not much helpful is, see, it needs some statistical background to understand a distribution. What this distribution is, ECDF, empirical cumulative distribution function. I not discuss much in detail because I had just 50 minutes. But to understand the outcome of this technique, we must have some background in statistics, and we must understand how the distribution works. So that is another point I would like to add here.
Okay. Um, so we had a couple of questions about quantiles, and if you could go into how the quantile method differs from the point method, and then is there a criteria for choosing which quantiles to compare? For example, when you did your 10, 50, 90 quantiles, um,
Uh,
is there a way to decide which quantiles to use for a particular problem?
I haven't heard, I read so many things I had in my hand, but I never found like what quantile is the best one. Almost everyone uses 50th quantile or median quantile. More than median quantile, what it always uses is, it uses something above the median quantile and something below the median quantile. So 50 to 40 plus 90 and 40 minus, that is 10. To 10, 50, 90 was my answer, which quantile to be used. But there is no hard and fast or no statistical rule I have seen at least which tells us which quantile to be used.
And just a quick, if you could comment on this quick question, what happens when you choose quantile of 100%?
It is the maximum method. It is the maximum value. You can choose it. It is the maximum value you can ever imagine with the data given to you.
Um, Subhashish asks, on what basis do, do you select a subsample from the main sample? Is there a particular logic or set of rules behind the segmentation?
It is actually not segmentation.
Mm-hmm.
It is bagging. Bagging is means you have big population sample, and from big population sample you keep on taking small samples, and that is the way we take the sample. At least every random forest is having inbuilt mechanism how much data to be used in a sample. Usually people take it as uh, they fixed number of sample like hundreds, 100 records, 500 records, but large number of samples need be taken from the bigger sample. What I shown in my presentation as a big circle, that is population data, and smaller circles, which is the thing. Otherwise, there is no rule like you cannot take 10 line sample or you should take at least 100 line sample. There is no such rule in that. But this is bagging process. As long as our sampling process is as per the bagging principles defined, we are correct. We can take the samples.
Mhm. Vimal asks a question related to preparing for a career in data science. What kind of math background does somebody need to prepare for a career in data science or in AI and ML? Is linear equations and matrices and determinants enough to know, or what other areas will they need to get a background in?
Okay. Uh, this is little subjective understanding of the things. I believe that four branches of mathematics are required to be learned. One is linear algebra and matrix, correctly included. Probability and distributions, uh, these two are needed. Then comes the vectors, how data vectors are there, which are used in the something like principal component analysis on that, the basis of vector, the angle between vectors and all that. And fourth is little of calculus. If
Mhm.
you would, being a data scientist, you want to understand how optimization method works. So we must know little about the calculus. What is a gradient, what is limit, what is gradient, all these things. So these four things are there, which in the mathematics are needed to be learned to learn the basic of data science. Now, again, there is a subjective answer. This is little, you may find it little vague, but how much of probability need be known? This is something subjective. I believe uh, we should know certain basic distribution and probability, certain basics calculus methods, certain basics matrices, of course, variant, sorry, inverse, and similar things need to be known. So, with these four branches and minimum knowledge of four branches, high school level knowledge of these four branches will be enough to learn the crux of the data science and machine learning.
Mhm. Thank you for that. Amelia asked a question about visualization and what type of plots you would use to identify outliers, and also non-visualization question, would it be a good practice to discard outliers, or do they provide valuable information?
See, outliers are the not always to be discarded. In many cases, outliers are the real data we are looking for, the real outcome we are looking for. Like in my last slide, what I discussed is something like a outlier method. Find
Mm-hmm.
out who are the people who are extravagant spenders. They actually break the distribution and their value is beyond the distribution. They spend more than 97 percentile of the value. So outliers need not be discarded. How to determine outliers? See, in the random forest, there is one very special kind of forest known as isolation forest.
Mm-hmm.
Similarly, if you see that there are various methods, one class classification method, one class SVM, one class, so many methods which are used for outlier detection. Here, just by seeing the distribution, you can determine whatever point is lying away from the distribution, that is the point is the outlier. Now comes to outlier visualization. Usually people use box plot to visualize the outlier. In that case, what happens is whatever falls behind second and third quartile, between 25 percentile and over the 75 percentile, is vaguely considered an outlier. Or in that range, many things are outlier. Again, definitions or the values are 25 and 75 are little subjective, but whatever found outside the box is an outlier, is a visualization used. Other visualizations that can be used, various methods have different visualization. One, we cannot say that which will be the best suited here.
Okay. Um, We have more questions than we have actual time for, but I will get to a few more if you can stay with us, Sunil. We had a couple of questions regarding preparation for a career in AI and machine learning. One of them is what type of experience and how long does somebody need if they're new in the IT field in order to become employable in as an AI engineer or AI practitioner?
Uh, I have a lot of experience, but not much. I cannot answer this because it's a little subjective how fast you can pick up, how fast you can learn the things and all that. But it's little difficult to say. But see, uh, start with data science, then jump to machine learning, and they then try to learn many things which are there in AI, but which is not the machine learning. And data science, machine learning is again divided into two parts. The thing which is one is machine learning and one is deep learning. So deep learning will be little difficult to catch up. Machine learning is rather easy provided we have some statistical and mathematics background. So this thing will do the job. I'm not sure how many years, but this should do the job. This
Mhm.
is this should do. This will help.
We have, I just put into the chat a link to one of our programs, one of the Simplilearn programs in AI and machine learning. And if you go to that page, you can also browse through and see other programs in the same category, depending on what it is you want to learn and how far you want to go. And those are things that build upon, you know, your foundations that Sunil mentioned about the different branches of math that you need to understand. And some of the programs include that training in math. Some are based on the idea that you already have it. Um, we have a question about a technique, and so Scott asks, what is the difference between OLS, ordinary least square method, and ALN? And his bias is that OLS he feels is suitable for machine learning, ALN for more traditional statistic methods. So first off, can you tell us what ALN is? Does that ring a bell?
ALM, even I am not exposed to ALM, but
Okay.
uh, ordinary least square is something which predicts the uh, point prediction, the conditional mean, as I explained in my slide. Quantile regression is something that brings us the range of that. Uh, range of
Okay.
that.
Okay. Um, yeah, I'm not sure he meant he meant by ALN, so I apologize for that. Um, and let's see. Kasi asked a quick question about the model. Or when you look at node purity, how are you measuring that?
What is node?
No, when you're giving a measure of node purity and you're looking at the node purity, what how is that measured?
Okay, this is little big process. While creating the trees, which are the nodes, which are the variables were used in the splitting the decision tree variables. This is how node purity is measured, like how many times it is used and how many times it has given the good prediction. That is how node purity is measured. But it is really big process. If you just search, this is a little big process to be explained in so fast. But basically my answer will be how a particular variable is used to determine the split inside decision tree or individual decision trees. It actually counts how many times that particular variable is used, and that is how node purity comes out in the picture.
Okay. And so the units in that column of are number of times it's used.
Yes.
Okay. That was the basic question. And let me see what else we have. Can you comment? Aditya has a question on the process of training AI for simulation of tasks. Is that something within your
No.
experience? Oh, okay.
No.
Yeah, this is a different, seems to be a different subject. What is overfitting and underfitting? Asks Sarab.
Underfitting is when you're underdoing the work of fitting the data. Underfitting example is you want to predict if some person will die from heart attack or not. And what you do is you just take the weight as input variable. So when you have very less number of variables, you cannot learn the actual data, actual causality, and that is underfitting. This is something like killing a lion with a small knife. Your knife is really not correct. Your unused data, or you're not use your data properly. You're not use your information properly. Overfitting is exactly opposite. Overfitting is you use all the variables and you really come out with a wiggly pattern which fits well in the training data and not fit well in the testing data. That is overfitting. So again, underfitting means using very less number of variables and making a model which is too simplistic, and overfitting means using everything you have and come out with a very complex model which does not work in the real world, which does not generalize well in statistics terms or machine learning terms, which does not generalize well, which memorize more. So that is called overfitting. So this is underfitting stands for bias, overfitting stands for variance, and random forest does a trade-off between bias and variance. So there are various methods to take care of underfitting and overfitting, and a random forest is having inbuilt method to do handle underfitting and overfitting in that case.
Okay. And there's a related question from Sudhir, um, who asks about random forests and the trees keep splitting down in the hierarchy level. Is there a point at which that could result in overfitting?
See, overgrown tree overfits data.
Mm-hmm.
Many techniques use data stump, which is just one level of tree. But what happens is overfitting get handled out because there are a lot of trees, and the overfitting results in variance. You have lot of trees, lot of variance, but variance can get averaged out and get reduced. So bigger tree creates overfitting, yes. Thus, individual trees in random forest creates overfitting, yes. But random forest overall results, which comes with the averaging of everything, reduce the variance. That is the way random forest helps.
Okay. Excellent. I think we'll take one last question here from the list because we're over time. But Ahmad asks, you displayed in the presentation the 10th percentile, 50th percentile, 90th percentile. When you mentioned the highest 97th percentile, would you elaborate on how that relates or what applications you would use that in?
See, for different slides, we run the model differently, we done prediction differently. 10 and 50 and 90 was the first slide, and 97 was used just to predict the extravagant spenders. So it is not that we always use 10, 50, and 90. We have used 97.5 also. We experimented with 100 percentile also. So everything we had done.
Okay.
And
And basically what you're saying is that depending on your application, if you're trying to find a confidence interval that your median is going to fall into, you might choose different high and low values in the or higher and low percentiles. If you're looking for an outlier, for example, you might look for the a high percentile or a very low percentile in order to see where values fall outside of the um, expected range. So
Yes, yes,
yeah,
that is what
okay,
I am saying.
wonderful. So Sunil, I think that's all the time we have for questions. I'm going to go back to um, my screen and I will share the closing slides. Um, so we will do a quick poll toward the end here. And I apologize to everyone whose questions we could not get to due to time constraints, but we will do this poll here. And again, my apologies for not being able to get to all of the questions, but these were excellent questions that were very insightful into the material. So very glad to have an audience with um, this level of interest and perception in this material. And so this quick poll is about what you would like to learn and add to your toolkit if you had the chance, whether you're at the start of your career or trying to move it up to the next level, and when you would like to start doing that. And here are the results of the poll. And not surprisingly, the folks in this audience are most interested in data science, AI, and machine learning. And it's good to see that about a third of you would like to start doing that right away. So as I mentioned in the chat, we do have programs in AI and machine learning. We also have other programs that you can see on our website, data science and all of these other disciplines that are on the poll here. And invite you to check those out. Meanwhile, I will thank Sunil very profusely for being here today and sharing with us his expertise. It's showing us a example of an actual machine learning model and technique so that you get a feel for what are some of the new things coming up in the field and how it applies and how it can be used in the real world. Here is his LinkedIn uh, information, so you'll be able to connect with him. I'll drop that into the chat in a moment. But thank you again, Sunil.
Thank you, Stuart. Thank you.
Okay, and with that, just want to mention our next Simplilearn webinar, which is coming up in 2 days, and it is in cloud computing and DevOps, and these are important new fields for technology. They're very quick growing. They're transforming how software is developed and tested and delivered. And dropping a link to this. Our speaker will be a digital leader from Accenture, Matthew David. And as I promised, here's also Sunil's LinkedIn information, so you can connect with him. We will be sending out an email tomorrow with a link to this presentation, the webinar. We can't share the PowerPoint of the slides, but you will be able to see that through the recording of the webinar. And we invite you all to connect with us and keep track of us at Simplilearn on Facebook, on Twitter, on LinkedIn. And we hope to see you both at future Simplilearn webinars and also to have you join our Simplilearn learning community. So thank you all very much for being here, and we appreciate it. This concludes our webinar today.